What's up, guys? We're in 2.6 family functions. A couple things here. Families. You guys know what those mean. You're all part of a family. That means things that are related, right? So things that are related, right? And what is a function? Functions are things that you can usually graph, right? And it's a straight line test, right? And it has a graph right here, and it goes up. It goes through 0, 0, and it goes, or it goes down. So we're going to talk about things that are functions right now. So, review. Cross out the items that are not vertical. What does vertical mean? Vertical means, think of the X Games. Let's get vertical. Vertical is straight up. So the y-axis, right? The y-axis is right here. So that is vertical. The x-axis. The x-axis goes this direction. So that is not vertical. The horizon, again, the horizon goes this way, not vertical. Columns. Columns of a house, right? Or columns on a paper. Here's a house, right? Right there. These are columns, right? They are not vertical. They are vertical. I'm sorry. Let's erase that. I don't know how to erase even. But let's just cross it off and say yes. And rows. Rows go across, and they are not vertical. So let's look at these words right here. Vocabulary builder. What does translation mean? Translation means, right, other word forms to translate. So you probably know this best with Spanish. How to translate it from one language to the next language. You're going to use Spanish. It's a noun, it's translation, or it can be translatable as an adjective or translate as a verb. Definition. A translation is a change from one form of state or appearance to another. Right? So Spanish to English, English to Spanish, probably the most common translation in your life. Math usage. A translation shifts, so moves, right, the graph of a parent function horizontally. That means that way or that way. Vertically, that means this way, or both without changing its size or shape. So the most easy one you probably did last year, you probably slid a triangle. Slide, right? You slid a triangle across the paper, called a translation. So number 2, using your vocabulary. Complete the statement with the correct form of the word translation. Now, the graph shows a vertical translation. We're going to go through this quickly because this is not a class where we want to promote just doing vocabulary. Adjective. The toddler's language was not translatable. And then we have verb. The Spanish teacher helped the town mayor translate the letter. Complete the graphic organizer below. Translation. See, right? This can be vertical. And this one is horizontal. Then we have K units, right? And this is going to be up. And this will make more sense in a little bit. And this is K units down. And these are H units right. And H units left. So this is back and forth, right? And this is up and down. And this is the K. Very close to the what we're going to call Y. This is the H, very close to what you call X. Not too far off if you're taking notes at home. So let's turn the page. Here we go. Vertical translations. How are the functions y equals 2x and y equals 2x minus 3 related? How are these two related? What's the difference? How are their graphs related? Well, let's look at them. We put negative 2 in for x for each of these, right? We're going to get negative 4. Negative 7, right? So negative 2 times 2 is negative 4. Negative 2 times 2 is negative 4. Minus 3 is negative 7. So every one is going to be minus 3. Minus 3. So let's watch this. I'm going to fill this in for you. You can follow along and fill in at the same time. Those are my first answers. And we just subtract 3 from each of these. We're going to get negative 5, minus 3, negative 1, and 1. Now we're going to graph these guys, and you can use Desmos at home if you want to, but we're going to just put 2 points here, the first graph, And we're going to go 2 up over 1 over, because that is our slope. So here's the first graph, right? And the other one is going to be a intercept of, let's look at the other one here. This is y equals 2x. Now we have 2x minus 3. And let's just pick a couple points here. -2 and -7, right? It's way off the graph. But it's going to be like down here. Let's do -1, -5 right here. -1, -5 would be right here. And we can also do 0, -3, right? That'd be the y-intercept. And then 2, -1. We have 4, 1. No, 2, 1. I'm sorry. And then 2, 1, and 1, -1. There's the graph. So these are going to be related because they have the same slope. And so we're going to say they have the same slope, so they are parallel. These are parallel lines. Definition of parallel lines: they have the same slope but different y-intercepts. Number 6. Write true or false for the statements. Each output of y equals 2x minus 3 is 3 less than the corresponding value of y equals 2x. And we said that, so it is true. The value of graph y equals 2x minus 3 is a graph of y equals 2x stretched vertically 2 units. No, it's not stretched. It just moved to the right. The graph of y equals 2x minus 3 is the graph of y equals 2x translated down 3 units. So, and you could probably look here. We have 1, 2, 3 translated units, right? So we would say true for that one. And number 4, the graphs of y equals 2x minus 3 and y equals 2x are parallel. And that is 100% true. Problem 2, the horizontal translation. Got it? The graph shows the projected altitude f of x of an airplane scheduled to depart at noon. An airport at noon. If the airport leaves 30 minutes early, remember noon we have here? 30 minutes early, that would be 11:30, right? So it's leaving at 11:30 now. I'll write that down so I don't forget it. So circle the graph below that shows the airplane leaving 30 minutes earlier. So here's the regular plane right here, and we're looking for the one that leaves 30 minutes earlier. So on the left side we have the altitude in thousands of feet. And this is hours after noon. Hours after noon. And this is hours after noon, right? And so here is 0. That would be noon, right? This would be 0. This would be noon. So this wouldn't be leave 30 minutes early, would it? No. This looks like it's 30 minutes after noon. Well, we're looking for 11:30. This looks like 12:30. Is this before noon? Yes, it's before noon. So this is the only one that can be the answer. All right, let's go to the next page. Circle the function that represents this transformation we just talked about. And it's going to be x plus 1/2, right? Function of x plus 1/2. That'll be your function right there. Reflecting a function algebraically. Algebraically is the key word there. We're going to tell you how to do that real quick. And reflection just means like a mirror image. Let h of x be the reflection of function of x equals 3x plus 3 in the x-axis. What is a function rule for h of x? And we're going to say right here, negative function of x. Okay, write the function rule for h of x below, then graph h of x and f of x to check the reflection. So we're going to do h of x equals negative f of x, right? And we're going to do h of x, keep on giving it there, minus 3x plus 3, and this negative sign is going to be distributed to both those parts. Any questions on that? So we have two things we're going to graph. We're going to graph the negative 3x minus 3 and we're going to graph f of x, 3x plus 3. So they both intercept right here. This one goes 0, 3, right? So it's going to look like this. This one is going to intercept at 3. This one's at -3. This one's at +3. Little sloppy graphs there, but you get the idea. So there's your 2 graph. And those are reflection. It's going to reflect over this -1 line right here. And here's a stretch and a compression. So here we go. For the function f of x in the table below, what are the corresponding table and graph for the transformation h of x equals 1/3 f of x? Right here. Boom. So let's put them in a graph. You put in 5, -5 for x. What do you get? You get 2 and 2/3. Here you get -2. You get 2/3 again. I hate letting fractions like this. Should be like this, but I try to fit in that space. 0, -3 is going to be -1. 3 is 1 is going to be 1/3. 5, -2 is going to be -2/3. And this is key here. You have the positive and the negative right here. So you can see where it's going. You also have another 2/3 right here. It's going to make this all jacked up, this graph. So we already have f of x. Let's graph the h of x right below it here. It's going to go to there. Then we're going to go to 0, 1 to here. And then we're going to go back up to right here to the halfway mark. And then we're going to go back down to the 5 right there. So that is going to be your stretch and your compression a little bit by the compression of 1/3. So 1/3 of that line. Everything is 1/3 of it. So one more question. We have about 3 minutes to finish this one before we do the lesson check. Combining transformations. The function f of x equals x. The graph g of x is f of x stretched vertically by a factor of 2 translated units down 3 units. What is the function rule for g of x? This is a lot of words, and I think you might be confused, but let's go through it slowly. Underline the correct word or expression to complete each sentence. The function f of x equals x stretched vertically by a factor of 2 is, right? And we're going to circle right here just 2. So a lot of stuff going on here. Remember, we're just going to stretch it by a factor of 2. So it's 2 times x. The function f of x equals x stretched vertically, right, by a factor of 2, and then translated down 3 units is what? Remember, translated down means what? -3, and this is stretched vertically, so it's going to be 2 multiplied by something. So same as before, it's going to be 2x, but then you're going to have that vertically down, so you're going to have this guy right there, 2x minus 3. It's a lot easier than it sounds. Don't make it hard. The function rule for the combined transformation is what? Well, we have g. We knew it was g. Right here it says g. We're going to write g of x equals what we just said, right? Factor of 2, right there, right, times x, and then it's down, so we know it's going to be -3. It's not as hard as you think, guys. So now we have the lesson check, and we'll do the homework together also. Have fun with the lesson check. You're going to draw 3 lines. Well, 1 line's drawn for you, and then you're going to draw 2 more lines to do the rest of it. And so remember, these are going to be parallel. This is going to just be an x here. This is going to be x plus 2, and this is going to be our not the same. And this is, if you look at all of this data up here, you're going to figure that out. So I kind of gave you the answer there. You just have to graph these 2 lines right there. And so have fun with that, and I will talk to you later.